Why Go is so efficient? The Go programming language is often described as small and simple. It has a relatively small standard library, and in addition, there are no real frameworks for Go. Nevertheless, more than 3% of all projects on GitHub are written in Go. Well-known technologies such as Docker, Prometheus, and even the TypeScript compiler are written using this language. But why did such a small language, with fairly limited built-in functionality, become so widespread? First of all, it became popular precisely because of this. The entire language has only 25 keywords, while C has 32, C has 72, and JavaScript has 64. This ensures excellent code readability and a fast learning curve. At the same time, Go is a relatively low-level language. When working with it, you need to understand how memory works and how it is managed. Of course, you cannot completely forget about memory like you can in JavaScript, but this gives you huge performance benefits and execution speed close to languages without a garbage collector. I consider this an ideal balance between C, where you manually manage memory using pointers, and Python, where you can write code without thinking too much about how the computer actually works. Frameworks in Go are simply not needed. The common approach is to build everything using simple functions and structs. If something becomes too bulky, you just write a wrapper. This philosophy encourages clarity and keeps projects easy to maintain. Another important aspect is tooling. Go is one of the few languages where the toolchain was designed as part of the language from the very beginning. Tools like GoFMT, GoVet, GoTest, and GoMod are not optional add-ons but standard parts of everyday development. As a result, most Go projects look very similar in terms of structure and style, regardless of the team or author. There are no endless discussions about formatting, no massive configuration files, and no complex setups. You just write code, and it works. The module system also deserves special mention. Go modules are simple and predictable, versions are fixed, dependencies are reproducible, and a project can be built years later without dependency chaos. This is especially important for infrastructure software, where reliability and stability matter more than trends. Go was also designed with large teams in mind. The language deliberately limits the developer. There are no overly complex abstractions, no hidden magic, and no multiple ways to solve the same problem. This can feel restrictive at times, but it makes code bases easier to read, understand, and maintain. When you open a Go project written by someone else, you can usually understand what is happening very quickly. Despite its simplicity, Go provides extremely convenient tools for writing concurrent programs. NuGo routines can be created almost endlessly, and the scheduler automatically finds idle threads and distributes the workload efficiently. Channels help organize safe and clear communication between Go routines without excessive locking. Another major advantage is compilation into a single static binary. You write a program, build it, and get one file that you can simply copy to a server and run. No virtual machines, no interpreters, and no dependency on the runtime environment. This is one of the main reasons why Go is so popular in the DevOps and cloud-native world. At the same time, Go remains fast enough for most real-world tasks. It may not compete directly with C or Rust in raw performance, but in practice, this difference is often negligible. What you gain instead is faster development, clearer code, and fewer long-term maintenance problems. In the end, Go is not about having fewer features, it is about conscious limitations. It is a language that stays out of your way and lets you focus on solving problems rather than fighting the language itself. And that is exactly why so many developers love it.